Hello, welcome back to Decaf-Math. I hope that you are doing very well. So today let's go over the idea of number lines. This is exciting because this is the first time that we are going to represent things visually. So we're really actually going to be drawing and plotting or graphing. And usually the idea of number lines are introduced in pre-algebra or algebra or so. Really just whenever you learn about negative numbers. And that's because this is a tool that we can use to visualize what's really happening. And when you're talking about positive and negative numbers, it's all relative anyway. So this gives us a way to see what's going on, especially when we learn about adding and subtracting and stuff. So let's just take it step by step today, make sure we have a good foundation, and we can work with number lines in the future. So let's say I have the number 3. What is 3? Well, when you're little, you learn to count objects. So 1, 2, 3, 4, 5, right? Guess we could get really philosophical here. 3 is just 3, but we assign it a value just from what we learn, right? So in whatever language we count 3. You can also think of 3 as 3 ones. So 1 and another 1 and another 1 gives me 3. And it's 3 away from 0. Now, of course, then we have to ask the question, well, what is 1 and what is 0? But that's the idea that we're going to use when we're going to plot this number 3 on a number line. So first things first, we need to actually draw a line, a number line. So I'm going to go ahead and draw a straight line. Okay. Now I need to have arrows on both sides to make it an actual line. Okay. Without the two arrows, I actually technically only have a line segment, because even though you can't really see the two endpoints, you stopped the line. So having two stops make it a line segment. A line, by definition, needs to go off to infinity in both directions. So that means that this goes off to infinity this way, this goes off to infinity. We'll talk about that, a negative infinity technically, that way. But the idea is that we can extend it as far as we need to. So if I just went ahead and kept extending this line like this is the same line. So we can just extend it as we need. And that's really important because we're plotting numbers, right? And numbers go off to positive infinity. They get infinitely big, right? We can have 10,000, a million, 500 million, etc., etc. And we can also go the same way negatively. So in order to actually plot numbers, we have to be able to extend our line as needed, right? So that's the first thing. So we need to draw a straight line, and it needs to have arrows on both ends. Now, just by standard, we draw this line horizontally for a number line. It will save you trouble on homework and stuff, and it will save your teacher some headaches, but you actually can, technically, if you're feeling kind of hipster one day, you can draw your number line diagonally, or really any direction that you want. It's really just a line that we can use to put a scale on stuff, and then we can plot our points, but it's all relative. Now, of course, having it horizontal makes it nice and pretty and simple to work with, but you can do whatever you want. The key thing is that it has to be straight, so we're not going to be working with number lines that look like this, although that would be kind of interesting. So a curved line is not going to do, aka a curve. So we're just dealing with the straight line. If for whatever reason you're obsessed with vertical lines and you want to make number lines this way, we're going to get the opportunity to do that later on when we're graphing the Cartesian coordinate plane. So for now, just go ahead and do this. Okay, so now that we have our lines, I'm going to say step 1, draw a straight line. Of course, if you chose to do a diagonal line like this or something, just make sure it's straight, and just you can do what we're doing now and turn your paper this way. Okay, so next thing is, by default in math, moving to the right means positive or plus, and moving to the left means negative or minus. Okay, so we're going to distinguish the idea of positive and negative numbers and the actual operation plus or minus later on when we apply number lines. But in general, you can think of it as moving to the right is adding stuff, and moving to the left is subtracting and getting more and more negative. Okay, that is set, and that's pretty standard. Unlike in physics and stuff, everything is relative. In physics, you actually set your relative, direction and stuff. So you can choose which way is plus and which way is minus as long as you're consistent in your calculations. For math, this is pretty standard. Okay, so we have to orient it this way, which means, and you don't actually have to label plus or minus. I'm just trying to show you now. But on your number line, it also means that there has to be some kind of transition between negative numbers to positive numbers somewhere. And that's our neutral number. That neutral number is 0. So you can pick a 0 and label it. Okay, so your 0 can be here if you want it to be, like that. You can put it here. And just for now, since it's our first number line, I'm just going to put it right in the middle. So you need to set a 0. And that's because everything is going to be relative to it. So now that I have a 0, this means that everything to the right is a positive number, and everything to the left is a negative number. Okay? So it's okay if you set your 0 here. It just means that you have more room on your number line to show positive numbers and not as much room to do negative numbers. But once you set it, we're going to work relative to it. Okay? And the next thing is we need to have equally spaced tick marks from this 0. This will give us a scale for us to work with, and so that's what's important. We don't actually care about the actual spacing of the tick mark, so you don't actually need a ruler. You just need a way to measure a constant distance so that tick marks are equidistant. Is that a word? Equidistant. So we don't care if they're actually, like an inch or a centimeter apart. It doesn't matter. We just need to have a constant distance. Okay. So in my case, I'm just going to go ahead and sort of eyeball it. Okay. So 3, put equidistant tick marks. as you'll come to see, the more that I do math and I'm explaining it, the less that I can speak English. I just drift off into math land. But I just make these equidistant, and this gives me it's kind of like a ruler, right? It gives me a scale that I'm working with, but now that I know that these are equidistant, I need to set actual numbers. So for all I know, this distance could be 10. It could be 100, it could be 2, it could be a decimal. By default, I'm just going to do 1, 2, 3, -1, -2, -3. The important thing is that since they are equal distance from each other, right, the numbers also have to be an equal difference from each other. So I can't just put 1 here and then 20 and then like 0.3. That doesn't make any sense. So as long as you set your scale, you're basically setting your 1. What is your 1? Then you're just counting from there. Okay. The reason I set my scale as 1 for this particular question is because I know that I'm plotting 3. So I want it to look kind of nice. So if I set, for instance, the scale to be 0.1, 0.2, 0.3, if I keep counting positively to 3, that's going to be like way off the page, because then I have 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1, and then I only got to 1, 1.1, 1.2, 1.3, so I'd be way off the page. So really you just want to set your scale so that it's reasonable for what you're plotting. So set and label scale. And really you only need to label 1 because that defines your unit. But you want to label more just because it's more convenient when you're plotting things. So you don't have to count every single time, okay? So once you've set your distance of 1 or whatever your distance is, everything is relative to that. So the number line gives us a way to visualize numbers, which means that the distance that's halfway between 0 and 1 is half. Okay, so you can fill in intermediate tick marks if you need to, if you're estimating things, okay? But just conceptually, it's all to scale there, so nothing changes once you set your 0 and your scale, okay? So as you would expect, the distance between 0 and 20 is halfway between 0 and 40. So you can physically see distances and relative and how numbers are relative to each other. So as you can see, to the right of 0 is positive, to the left of 0 is negative. So if we're trying to plot 3, I can either just find my 3 on my scale, which is right here, and put a dot right there. Or I can start from 0, wherever I set it. Remember, we had a step 2, we can just pick a 0, and count 3 units to the right. So wherever my 1 is, hopefully you picked it so that it's convenient to see. Because for instance, if you set this number to be 100, and this is from 0 to 100, to plot 3, it's going to be teeny, 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 right? Because halfway is going to be 50, a quarter of the way is 25. It's going to be teeny, teeny, teeny right there. That doesn't do very much, but on that scale, it's kind of small. But for this scale, we can start from 0 and go 1, 2, 3. And I found 3. So I put a dot there, okay? And that's it. We just plotted the number 3. You don't need to do this, although it's typical to start thinking about counting this way. So we kind of do these little humps. But really the plot is just a line with your tick marks and a dot at 3. So remember, this is just a visual aid, okay? theoretically, numbers, if you put a dot there, they're infinitely tiny. Okay, so you don't want to make a dot that's like gigantic here. It's really just the idea conceptually is you're putting a dot, a teeny tiny dot. Even my pencil has a width, right? So when I draw this line, we want it to so that we can actually see what's happening. But conceptually, lines are infinitely thin, and the dot you really can't see. Because technically, if you look at this dot, it could also be 3.00001, right? You just can't really plot that between 3 and 4. But I just wanted to point that out because conceptually, it's visualizing things can be kind of deceptive sometimes. But for now, that is how we plot it. We have our number line, we have a dot. So similarly, if we're going to plot -4, I can use the same scale. It looks pretty reasonable. I can just find -4 and put a dot on the tick mark that corresponds to it. Or I can start at 0. And because it's -4, I'm going to go 4 units left. So 1, 2, 3, and 4. And then just put a dot there. And that's -4. So that's it. So just knowing positive versus negative for now will be great. If you want to plot some fractions, you can do that as well. For instance, 1.5 would be between 1 and 2, and 0.5 is half. So you're actually going to be plotting halfway between 1 and 2. Stuff like that. You could estimate pi, 3.1415. I hope you know 100 digits by now. No, I'm just kidding. But between 3 and 4, you can estimate it. It goes on, but you can estimate it. Putting a dot somewhere around there. Right? So you can play around with this idea for now and get a sense that it's all relative. So even from this picture, we can start kind of seeing that we can figure out what, 3 minus -4 is. The minus means you're finding the distance between 3 and -4. And so when you're finding, the difference, it's really finding the distance, although you're going to need to always take the larger number minus the smaller number, unless you know about absolute values. But really, we're doing 3 minus -4, and if you learned it in algebra already, this is 3 plus 4, which is 7. And really what you're doing is counting the distance. So from 3 to -4, we're going 1, 2, 3, 4, 5, 6, 7. So that's the distance between 3 to -4. And number lines are helpful in this way because we can actually visualize that it was exactly 7 units. 7 units of 1, according to our scale, right? And that's it. So I hope that that is a good little intro. So set and label scale, plot point, and remember, plotting the point, it's going to depend on if it's positive or negative, whether or not you're going to the right or the left of 0. And remember, 0 is all relative anyway, so if you set your 0 here, you can have a whole bunch of positive numbers. So from here, we're going to build on this idea. We can work with absolute value, we can work with inequalities, we can do more with plus or minus, and stuff like this, plus or minus with negative numbers with this number line. So we'll have fun with it, but I think for now, the best thing is to practice plotting. Do it on your own. We might even do this in a sleepy time video if you want, but that would probably really be boring. But I think for now it makes sense to just get used to drawing your own number lines. And so I wanted to point out that we are only plotting in one dimension right now. So we have have the choice to go either left or right from 0, right? So there are two directions we can go, but we're really only ever staying on this one line. So it's called one-dimensional, as opposed to moving up and down as well. So you shouldn't have a point that goes like up here right now. Although that would be fascinating, wouldn't it? Well, I'd be glad to plot that with you in the future. But for now, we're just going to stay along this line, okay? So it's one-dimensional. Okay. Okay, so I hope that this was at least a little bit interesting. I wanted to just kind of take my time in setting up how number lines work, and I think it's worth it because when we start building off of this stuff, sometimes people just kind of assume that everyone knows the obvious stuff, quote unquote obvious, and it's not always that obvious. So I hope I answered any questions, and if nothing else, I hope that this was sort of relaxing. Thank you so much for hanging out with me. You can definitely expect us to build off of this in the future to get more ideas of what's going on with negatives and positives, absolute values, inequalities, stuff like that. But I just wanted to set this up. So have fun drawing your number lines, and good luck if you're doing homework on this or anything else, okay? Let me know if you have any questions or if I can support you in any way. Subscribe to this channel if you want to see a whole bunch more of math videos, and I will see you around. Bye!